Hi everyone, welcome back to Cloud on Air. My name is Jay Jenkins. I'm a customer engineer based here in Singapore. Earlier today, we heard from Smart Parking out of Auckland talking about their IoT core infrastructure and some of the serverless applications they're using to help with their real-time data pipelines. We also heard from Omise talking about their payments platform and how they're using Kubernetes or container-based applications to help scale out and create highly available API payment gateways for their customers. In this session, we have GO-JEK talking about their next-gen data warehouse. Joining me, we have Dimas and Johannes. Remember that at any time you can ask a question below, and we have experts standing by ready to assist. At the end, I'll take some of those questions. I'll bring them back to GO-JEK. So if you have any questions specifically for GO-JEK, please note in the questions below. So with that, let's bring on Dimas and Johannes to talk about GO-JEK's next-gen data warehouse.
Hello, Jay.
Hi.
Hi.
Great. Thank you so much.
Yeah, sure.
Yeah.
So,
That's good introduction from Jay Jenkins.
Yeah, so thanks, Jay, for introducing us in here. So, hi, everyone. I'm Johannes Alexander. In here, we're going to presenting GO-JEK's journey on how we're getting from old data warehouse to the new one, to the BigQuery, that we called our next-gen data warehouse. So, from here, I want to say thank you to Google for having us here. We hope that our journey, our experience can help you guys out there on leveraging the cloud and how you can design and learn about our mistake as well.
Sure.
So at this part, we're going to have segregated into 3 parts. We have the introduction, a journey, and also the takeaway from our experience. So for introduction part, I'm Johannes Alexander. I'm the lead solution architect here in GO-JEK in business intelligence team.
Yeah. So, hi, Joe. My name is Dimas Jiwa. I'm a data warehouse manager in the business intelligence department. So, before we are going to the deep about our tech, we will start about how GO-JEK started. I believe not many of you know, in 2010, GO-JEK actually started as a call center for OJEK services, where 5 years later, we are launching a mobile apps. We are evolved into the mobile apps and launch our 3 main services, the Go-Ride, Go-Send, and the Go-Shopping. Where we have a target to be a mobile app for the daily needs, we are expansion to many service area and provide many services in 2016. In Indonesia, so if you need to know, we have so many challenges for the informal sector. There is a 3 main part for that. First, inefficiency and the competition part, limited access to the customer, because in earlier days, when we want to get an OJEK services, we need to go to the bigger street.
Yes.
Or maybe if you want to get a massage services, you need to ask to around your neighborhood, right, to get them go to your house. And the third one, for the limited access of the financial services. Because many of informal sector in Indonesia only think about how they get paid for their today's living only.
So, given all of those challenges that we're facing in Indonesia, we at GO-JEK we're thinking probably we can create a solution for every customer needs. So, here in the screen, you can see there's a lot of services that we have. So we have the transportation. It's covered for Go-Ride, Go-Car, or if you want the taxis, you can have Go-Bluebird. We can have also the merchant related. So we can buying food via GoFood, or you can buy shopping a daily needs via GoMart and GoShop. And also for everyday's life. So it covered from the paying bills, buying some movie tickets, and also get your home clean up. And all of that is supported by the GoPay. It's our primary payment method that it gives the easiness for people to using Google's GO-JEK services.
Yeah.
So after a year, this is the stats that we have. So far we have more than 70 million app downloads. We also help more than 125,000 merchants. We operate throughout 50 cities and becoming more later on. We also have 900,000 drivers, which help 2 million people, 2 million families out there.
So, after we got what is GO-JEK, that explained by us, we need to start our journey.
Yes.
Around 2016 at Q3,
Q3.
We are starting to build the business intelligence teams, where at that time there is no single place for us to know where's the single version of truth for every data. If you want to get a transport data, then you need to go to TransportDB.
Yes.
If you need to have the food data, you need to go to FoodDB. there is many backend process across there, and then many backend DB across there that make us to have more time to deliver the business insight.
Yeah, giving all of those conditions, you can imagine that a lot of business analysts is doing a lot of things by connecting to every database, extracting the data from there.
Yeah.
There is a really labor-intensive work in there, and it costs us for the delivering the business insight.
Yeah, that's correct. Because of that, we are starting to use this design.
Yeah. So we're thinking based on design rationally, we're thinking is what is the best way based on our use cases we can handle all of this problem. So everything will start with the pyramid, if you can see in the center of the screen. We divide it based on the staging layer, integration, access, and the data mart itself. DM is a data mart. So staging is where we combine everything, all of the data from every services, every databases, we pull it out and put it into the staging level.
And in terms of access level, you can see it have high accessibility in the upper layer and the lower layer one. Why? Because the BI developer and high level management is the people that really know about the data, right? But for the BI analyst thing, they have the low accessibility because they have knowledge only on the access and integration layer.
So beside of that, we also have the integration layer where we change the point of view from the data itself and store it the summary level in access layer, and also divided all of those data into product level in the data mart layer. So beside of that, we also have the granularity covered. We have the high granularity data stored in the staging layer. We also have the low or the summary data stored in the data mart layer.
Yeah, that's correct. So this is what we are implement based on that design rationale.
Yes.
Like I mentioned previously, we have so many data sources out there. We have the MySQL, we have the PostgreSQL, MongoDB, anything, you can name it. We have the APL, even file can be our data sources. And all of them are covered by our transformation tools using the Pentaho and the Python one. All of the data being transformed and put into one PostgreSQL as our data warehouse.
Yeah. From there, our business analysts and also high-level management can access the data through Tableau. Or if they want to do some data analysis, they can use Jupyter. And also the simple slicing and dicing data via Metabase. All of this is covered, supported by the operational and monitoring tools that we have. We have some custom tools, and we have also the Datadog.
Yeah. So, based on that architecture, what we implement, we are achieving this in the beginning of 2017. We have around 27% of growing data volume per month with more than 100 low-resolution dataset. You need to put this point, it is a low-resolution dataset, where it is providing more than 400,000 Metabase cards and Tableau sheets.
Yeah. Don't forget that 4,000 Metabase cards and Tableau sheet is accessing by more than 400 average daily users every day. Yeah.
So, these good old days, is it still good?
Yeah, so at this experience, the pain starts coming in, right? So when we are opening up our data, everything can access our data warehouse. We are having some problem. We have the performance problem, performance issue, scalability issue, and also the operational issue.
Yeah, with the huge data coming in, the process is getting slower and slower, and also we have a limited scalability in there, and we need to realize in the morning that our report is not getting updated.
Yeah.
So we need to firefighting in the early morning to make sure everything is get corrected again.
Probably it's not good already.
Yeah, of course. So then, based on that, we are expecting a new data warehouse where we have a high performance one, scalable, minimum operational and maintenance. We have the full resolution data set and easy data discovery process, right?
Yeah, don't forget that one is pretty important. If, let's say, if you already have hundreds of tables, thousands of data points, and everything is keep coming to you and asking, hey, where can I get this data, and etc. So the data discovery process is very important to have.
Yeah, that's why at the time we realized GO-JEK already provide that. GO-JEK already provide GoRide. If you want to go to somewhere just by yourself, or you want to go with your friends, you can use the GoCar. You do not need to think about how you are maintaining your vehicle or where do I need to park my vehicle. You just can use the GoRide and GoCar, right?
So it is the same of what we think that we had with the Google Cloud Platform.
Yeah.
So we have the compute engine where all of our infrastructure is running. We don't need to care about the maintenance, etc. We have also the Google Cloud Storage where all of our data is stored there, whatever the type, whatever, how big is it, we doesn't really care about it again. And also the BigQuery where we store all of our data warehouse data where we can easily do the all-up thingy, the analytical purpose thing. And also don't forget about the data flow where we can only focus on code, focusing on the transformation, creating the insightful data, and no need to care about the infrastructure itself.
Infrastructure, yes. All of them are paid as you use,
Yes.
right? All of this infrastructure that built in Google Cloud Platform, we call it a next generation data warehouse. Before we building that, we design all of the new data warehouse into this three main part. We have the data lake, we have the data warehouse, and we have the data mart. In terms of access layer, there will be no differences because in data developer and the high-level management for the lowest one and the highest one, it's still the people that really know about their data, right? But in terms of the business analysts, they have the data warehouse that already have a structured data.
Yeah. So for the granularity part, it's also still the same, but we're adding more and more details. We have the variety details where we stored all of the structured data, semi-structured, unstructured in there. We also increase our availability data into the real time.
Yeah.
And not also to forget the governance part, where we learned that we never covered that part previously. And right now we are stricting the governance part where we need to have a stricter access for the data mart layer where it can be only accessed by the high-level management, and also the more tolerant one in the bottom one, where everything can go as it is from the source.
Yeah, we want our data is become self-explanatory, so that's why we are put a naming convention there from the table into the column, even the data type,
Yes.
right? So after we have the next generation data warehouse, we are achieve what we want. We have now the high performance data warehouse, the scalable one, the minimum operational maintenance. We can put all of the full resolution data set in there and have an easy data discovery process. Do you know why we can achieve all of this?
Yeah, of course. I mean, like, it's not the data warehouse can stand alone. There is a lot of complementary systems around it. So we build the wrapper as a universal job executor. We also use the Airflow for all of the job dependencies and orchestration.
Yeah.
We also create the normalized table for our preferred data modeling. We also leveraging the cloud data warehouse by using the BigQuery and creating the data decks for the universal data dictionary.
Yeah.
Yes.
We have built so many things. That's why we will go one by one. We can go with the ingestion and transformation part, continuing with the storage, the data modeling, data governance, and the operation part.
Yes, let's go.
Start from the ingestion and transformation. We have the batch data modeling in here, where it has so many pros, right? It can be simple data processing because the data completeness is guaranteed, and it is good enough to cover most of the analytical that used by the business side.
Yeah, but of course, that's also have so many cons, right?
Yeah.
The top of it that we have is the data availability is low. So at the beginning, probably it's not really feel. We haven't really feel it, but right now we in the fraud, etc. For the campaign, we need more actual data. We need to have the streaming data, and also we have also the huge processing power problem where the data is getting bigger and bigger, and we need to process it at once.
Yeah.
That's become the operational effort problem where we need to migrate all of the data from hundreds of databases into our data warehouse.
Yeah, that's why we are starting to announce the streaming pipeline, where the pro is dismiss all of the cons. It have a data availability in real-time manner, or maybe a micro batch if you want, and it have the not very huge processing power because the data that being processed is not that much. And in terms of operational effort, beside rather than we are getting directly to the each DB, to each backend, we can go creating one streaming pipeline so all of the product can putting their data into there.
Yeah, but it's also have some difficulties along the way that we feel that we need to rethink on how we're gonna architecture the data, on how we're gonna implementing the business logic. Because other than that, the learning curve is a little bit steep for everyone to doing it.
Correct.
So we're still finding the way on how we can leverage this streaming pipeline.
Yeah. So this is what we improve with the next generation data warehouse. In terms of which, we are announcing the ELT process, the extract, load, transform in the BigQuery, because the high performance from BigQuery offering us to able to build the transformation just by using the simple query.
For the simplicity part.
Yes, and creating another table based on that. And for the complex transformation, we can use the ETL process using the data park with Spark. And this help us to improving data availability from daily to hourly.
Yes. And for the streaming, we also build a lot we work together with the product team on how they can make the data available through the Kafka or PubSub. We also build some general ingester to consume the data from the Kafka and publish it into the BigQuery. And also we start on focusing the data quality itself and on how we're integrating the data with the business logic.
Yeah. So as continuation from the ingestion and transformation, we now talking about the storage.
Yes.
In the all data warehouse, we put everything in the PostgreSQL. It have some pros that it capable to handle transaction data as it is, and it have indexing capability. In terms of access level, we can grant the permission go to the table level. Yes. But still, the cons is very big. We have the huge operational effort because as many data that coming in, we need to do more reindex for the bloated index, right? Or doing the vacuum and everything.
Yeah.
It have also the limited performance and limited scalability.
Yeah, so other than that, we're also facing the problem where we have a lot of unstructured data coming to us right now. Right? It can coming from the API and something like that. So we need a place where we can store all of the data as it is to be transformed later on. So in here, we are choosing the Google Cloud Storage as our new data lake. And in here, we are achieving that. We think that there is no ops at all. It can handle all of the data and also store the data as it is. And plus, we doesn't really care about the storage anymore.
Yeah, sure.
And related to this, related to our usage, we feel there is no cons for using this.
Yeah. And for the next generation data warehouse, we are using the BigQuery now. It has so many pros. There is no operational needed. It have high performance and perfectly designed for our OLAP thing, right? Except there is still some cons in there. There is some loss of indexing capability, which is a pros from our old data warehouse. Access layer is coming from the dataset instead of table layers. And probably it is not the best solution for store transactional data.
Yeah, because basically we're trying to put everything, all of the data that we have in the old data warehouse into the new one, and we start feeling that probably that's not all of the not all of the use case can be covered.
So after we are talking about the storage thing, we are now go to the data modeling because it is important. We are using the star sim part. In this case, we are dividing the table into two types. There is a dimension and a fact table. For the dimension, we can have a customer dimension, merchant dimension, a driver dimension, where it contains all of the details from this each dimension table. And for the fact table, in this case, we use the GoFood as a sample. We can have an order fact table, item fact table, driver search fact table. All of them are contain each detail from each fact transaction, but contain also the ID of each dimension table, right? And
so as you can see in here, all of those data that presented by Dimas previously in the previous slide, we have all of the data that correlated for the GoFood transaction. It also concludes all of the data flow. So in here, we're presenting all of those data into one big giant table. So where the user doesn't need to do some SQL, some queries, they just need to do select from one tables and they can have the clean and structured data model. Everything is one place, and also it covers, it gives the complete insight from end to end of the data flow itself.
Yeah, that's correct. Where previously we only offering the summary level data, and when they want to do deep dive of the data, they need to do a query again. But with this nested normalized data set, they do not need to do it again, right? They can do a deep dive after doing some summary tables. So after that, in terms of data governance, we have this kind of user mapping.
Yeah, so we create also the user mapping as our experience with the previous one. We think that we need to know on who get access to the data, what kind of data granularity that they will have, why do they need it, and also how do they access it. So from here, we divide the who gonna get the access is based on the high-level management, the business analyst, and everyone else, and also the data developer. And they will get a different kind of granularity as well. So the high-level management will focus on business summary data, and business analyst will focus, and the medium one, they can have access into the low granularity data, and also the high one for the raw data. And for the data developer, they can have access to everything, primarily the raw data.
Yeah. So why we are designing like that? Because it is based on their needs. The high-level management will need the data as their decision support system, right? But for the business analyst, they need the data for their hypothesis analysis. And especially for the data developer, they will have an exploratory analysis or maybe creating a new system based on their data. And how they can access it? For high-level management, they have a worksheet or reports in Tableau probably or in Excel file, they can do a simple slice and dice operation, where we can also have possibility that high-level management doing an SQL queries on our structured dataset, the nested normalized one, right? But for the business analyst, it can have the same worksheet or report, but in terms of query, they can use the more complex query because they're using it for the hypothesis analysis. And for the data developer one, they will create something like a machine learning thing, or maybe visualization, statistical analytic for why they need the data. And
okay, so for this, probably you imagine on how we're going to apply those user mapping metrics into the real life situation. So in here, based on high-level management combined with the identity access metrics, the group, and the cloud storage as well, we're thinking on how we're going to having this on real life. So what we do for the high-level management, they gonna have access for the BigQuery user, but they not gonna have the access for the Google Cloud Storage other than for extracting maybe. And also they have the BigQuery dataset for the data mart, where all of the data is configured, conditioned to have one simple definition and everything.
Yeah, and for business analysts, it can have the same identity access management with the others. It have the BigQuery user also, but now we are announcing the Google Cloud Storage as their shared storage to put or exporting their data for their hypothesis analysis, right? And in BigQuery dataset, we have the data mart and the data warehouse announcing to them.
Yeah, and for the data developer part, they will have everything those two that have. Plus, they can access to the production buckets where they can store all of the system programming language that they build, the ETL process into the production bucket. And also they have the access into the data lake where the data stored as it is with different configuration and etc.
So continuing for the data governance, we have also the data discovery. BigQuery provides us a capability to write the description directly into the tables. So by seeing the tables, we can see what is the meaning of column ID, outer column, something like this. And then not only that, from what the description that we are filling into the tables, we can extract them into one files, right? These files that we as a foundation to help us building a data discovery tools, so everybody in the business can get informed about what is specific metrics or what is data points that they need.
Yeah, because when you are starting, just like we said previously, when you are starting having a lot of data, hundreds of tables, thousands of data points, you will start getting the question, where can we find the data? So that's why we're building this prototype. It's called the DataDex. So it's coming from the Pokemon, Pokédex, and something like that. So from here, we store all of the data that we extract from the BigQuery, we store it, and we present it into the Kibana. So what we build is, we have all of those table information, what is the name of the column, the description of the column, the type, and also the correlation between it. So as you can see in the screen, if some people is typing in, I want to search for the merchant name for the GoFood related, they can put the merchant name in the name of the column and also the GoFood in the table. And it will resulting all of the tables that contains GoFood and the merchant name on it.
Yeah, you can see the table name in here is access.sd GoFood booking with merchant name as a column name, right? So continuing for that, we also go into the operation part. This is a very important part because in here we have the application management. In GO-JEK, we are not limiting all of our data developer into one programming language. It can be a Shell programming language or maybe a Python, a Java, Scala, yes, everything. But for sure, all of these programming language need to have a mandatory function that already defined by us previously.
Yeah, this mandatory function is covered a lot of like the data definition, on date definition. I'm sorry. So it's related on how everyone can build their own ETL tools based on their preferred programming language. But what they need to do is they need to wrap it so everyone can have the same definition. So let's say if I build something with Scala and Dimas want to rerun all of the data, all of the script that I built based on Scala, Dimas doesn't need to know about the Scala thing, but they just need to have some input, same output with others to backfill or to refill the data.
Yes, we call it a wrapper, right? The universal executive framework for uniformness in terms of running jobs or do rerunning jobs, right? So after we have this wrapper thing, all of them are go to the dependency management, where it helps us manage the dependency from hundreds of jobs because all of our job is intercorrelated. It also helps us to manage the scheduling part, the orchestration, and it have also functionality of the monitoring and alerting. In this dependency management, we choose the Airflow.
Yeah, other than also the monitoring for the job itself, we need to have the monitoring in the infrastructure part. So we need to check for the health. We also need to have alerting for certain condition with the infrastructure itself, and also when we need to do the deep dive analysis in the certain time frame. So in here we have other than the Datadog that we have, we also have the stack driver and use Grafana for these monitoring tools.
Yeah, so we already go all of them one by one from the streaming part, ingestion,
Yes.
right? And then the storage, data modeling, data governance. We will recap all of those into one summary table like this.
Yeah, so we think we have gone through a lot. You have seen the ingestion part, the streaming part, right? And also the data modeling, the operation, and also the governance. In here, as you can see, we recap all of these things, and also the part where we have before the good old days architecture, where we only have batch for the ingestion, and for the transformation, we only use Pentaho and Python. Where in the storage, we need to have all of the data get structured, put it in the table, and put it into our Postgres data warehouse.
Yes, for the data modeling part, in the old data warehouse, we're using the Snowflake,
Yes.
right? Where we have all the raw data going up layer, it is going to the summary one, aggregate again, everything is going to be in summary layer. And then for the operational part, we're using our own DAG at the time, where we are logging every jobs and then waiting until the job is done before continuing to start another job.
Yeah, so basically we just have all of these tables is logging it. We insert to some tables, and every job, other job will read to this table.
Yes, that's correct. In terms of access, we just use what the Postgres is providing for us.
So other than that, we're gonna move to the next gen data warehouse, which we are presenting right now. So we have adding more capabilities for the ingestion and also the transformation. Right now we have batch, and we also have streaming, and we have different tools for it. We have the ELT process, the Spark process, the Python process for batch, and we also have Flink and also Python for the streaming one.
Yeah, and in terms of storage, now we are announcing the Google Cloud Storage as our data lake, and we have the BigQuery also as our data warehouse, right?
And for the data modeling itself, we have the source scheme and also the denormalized tables. So this one is covered our data modeling, and also for the operation part, we have the dependencies. We get help using with Airflow. We also have the wrapper, which is based on the shell, and also the monitoring for the Grafana.
Yes, in terms of governance, now we are announcing a new governance part by help from the Google groups, and also the EM in the Google Cloud Platform. Yes.
But we think along the way, we're facing a lot of problems that we think it needs to be tackled in the next generation. So far, we're gonna give you some glimpse of what we're gonna build next. So some project is called the Modern BI thing. So in here, for the ingestion and transformation part, we're gonna streamline all of the data ingestion part that we use. We're trying to have everything ready in data flow, and also use probably custom Scala, Java, Python.
Yes, correct. In terms of storage, now in the Modern BI, we will have also still the same, maybe the data lake using the Google Cloud Storage. We have also BigQuery as our data warehouse. But now we need to rethink about our transactional or time series databases. That's why we are starting to see about the Cloud SQL, all the big table thing.
Yeah. And also for the data modeling itself, probably we will have some needs to have the key value stored. Right now we doesn't have it. And also for the operation, we're gonna introduce some of the Python wrapper because everyone's of Python in BI, probably in GO-JEK. And also for the monitoring part, we're gonna migrate some of it into the stack driver. And also we're gonna have the deployment manager.
Yes, correct.
To pack all of these things so we can create just another project to have BI ready.
Yeah, and in terms of the governance part, we still rely on the Google groups to controlling our access control layer. And in terms of data discovery, we will make sure the data lake is ready, right?
Yeah, we're gonna production that one, and also the others for the data reduction. So we think probably right now we have a lot of tables with a lot of customer phone, driver phone, and something like that. We try to redact those data. So probably Google DLP would be helpful with that.
Yes, correct. So this is our architecture by end of 2017.
We're growing a lot.
Yeah, so much growing in there. In terms of data sources, you can see we have also now the ESB as our streaming data sources, and we have also a ClickStream, right, as our data sources. But you can see also in the transformation layer, we are having now the Spark thing, the data port, the Flink for
getting
our
huge,
streaming.
right?
Yeah, sure. And then in terms of storage, we have two options. We can choose the Google Cloud Storage as our data lake to put all of the data type as it is, right? And then we can choose also the BigQuery as
Yeah.
our data warehouse thing.
And also the Postgres is still there. We're gonna start wrap up. We're gonna
Yes.
finish the migration part soon. And also for the presentation, we're adding the Shiny because some of the part statistician in our is
Yeah.
using the R. And for the operation monitoring, it's growing a lot. Sure, we have the Airflow for the job orchestration, monitoring, and etc. We have the Grafana, Datadog, and Stackdriver for the infrastructure one. And also we're trying to play with the deployment manager for packing all of those things together so we can have one-click deployment.
Yeah, correct. So based on this architecture, this is what we achieved at Q4 2017. We have more than 30% growing data volume per month now.
That's only for the business metrics.
Only
right?
for the business
it's
metrics.
Not covering all of
Yes,
the raw
because
data.
still
that we
have many data that's still not acquired yet. And we have more than 150 multi-resolution dataset. It is different with the previous one, only the low resolution.
Yes.
Now we have the multi-resolution dataset. It is covered also by more than 1,000 data points,
Yes.
right?
And it's growing by 1/3 by resulting 6,000 metabase card and tableau sheets, and also it accessed by more than 500 average
yes.
daily users. So just like everyone just love data now.
Yeah, sure. And then after that,
So it's all good now. So probably this part of the reality one. So it's not really. So the migration itself is pretty hard. It's super hard.
Super hard.
So some of the top point that we are presenting here is we have almost two quarters of migration activity, because we migrate hundreds of tables, thousands of data points in here, and it all require our careful planning so we can migrate it without a downtime.
yes, because there is no downtime that accepted, right,
Yes.
by the business user. And then apart from that, we have also defined our logic about how we are transforming the data. Previously, we are using the Postgres as our transactional data, but now we have the BigQuery, so we need to make sure all of the data becoming good for the BigQuery,
Yeah.
becoming on OLAP data, right?
Yeah. So other than that, we also need backup. We need to have a dedicated resource for this. We also need to manage on how they not to get bored with this. There's a long running process on how we're migrating it, and also we need to rethink on how everything is working, so it can be used in the BigQuery itself.
Yeah, sure. And then I think we can continue to the last part,
Yes,
right?
the takeaway.
takeaway. So this is our takeaway to you guys for our helpful tips, probably based on our journey. For the first thing, you need to make sure that every use case is considered before you are decide to go or migrating your data warehouse.
Yeah, based on our experience, we're trying to move everything from the Postgres into the BigQueries.
Yeah.
It's solely based on the needs of execution time. I mean,
Yes.
like, we need to have a more powerful scalability and everything. But along the time, you will find that some of the use cases probably cannot be covered perfectly
Yeah,
by
not suitable
by
enough,
one
right?
of the
Yes.
by one of the system. So probably you need to think on the complementary system that you need beside your data warehouse.
Yeah, and don't forget, put your data governance on your priority from the start. Why? Because once you are providing data to all of the business, we need to make sure that data going to the right people,
Yes.
not going to the wrong people, because it can be a fatal thing,
Yeah,
right?
this one is also important because giving the data to every people is having the pros and cons.
Yes.
You will have a bigger responsibility, and you need to check whether this data is good enough to see by
yeah.
this kind of people, but not by the others.
Yes, and then the last part is the application management is important to have, right? If your company have a limited programming language, then probably it will not causing a lot trouble for you,
Obvious, yes.
right? But in GO-JEK, we are not limiting any programming language for our BI data developer. They can have anything programming language that makes sure all of this application can be used one single uniformness of executor tree.
Yeah, this one is also helping for everyone that want to develop. They don't need to have some preferred language. They can just build on their own based on their preferred programming language. What they need to check, what they need to solve is on how they can make it uniform, so everyone can do the rerun,
Yes.
back to the data, and etc.
Yes. So I think that's all from us.
Yeah.
Probably Jay will help for the Q&A.
Yeah, fantastic. Thank you so much.
Yeah.
Yeah.
That was amazing. You guys got through a lot,
Yes,
and you
very
guys
lot.
talked a lot of products that you're using, as well as a lot of open source tools that you're using as part of Google Cloud Platform. As you can see on this screen here, there are quite a few questions that have come through. So a lot of good interaction on the questions. So thank you so much for that. So look, let's take a look at some of these. So, and maybe I'll take that first question and sort of make it a little bit broader. So it says, did you consider things like Google Firebase and Firestore and Firebase storage, cloud functions, or are you only using sort of those GCP services?
Yeah, so I will take this question. So yes, we are also not only the Firebase and Firestore, right? So previously we only think about data warehouse because our use case limited to that. But now our data is growing a lot, and we are starting to thinking about the Cloud SQL, Bigtable, probably the Firebase, Firestore, because we have the streaming data pipeline currently, right?
Yeah.
And for the GCP part, yes, we are only using the GCP for now.
Yeah. So I mean, I think because I also helped sort of answer this question while they were having the chat. So there's also some limitations you need to think about with Firebase and Firestore. You guys have a lot of users and a lot of data coming in through that, right? And Firebase and Firestore have certain considerations that you need to make whenever you're collecting that data, whenever you're talking sort of, not just 100,000 connections, but if you're taking real-time data stream, would you say 400,000 daily active users?
Yeah.
So that's a lot of users. So you really have to think about how you might partition
Yeah,
that data.
that's also one note that we're trying to say is like we're building some of general function in here. So we're trying to cover a general function as lot as we can. So probably we're gonna take a look by the cloud function itself, but for now probably not. We're still trying to build the general one for everyone. Yeah.
Right. Okay, fantastic. Thank you. So do you have any uses in regions where Google services might be restricted, such as China?
Not
yet for
probably
the moment.
yes, not for now. Yeah.
Not for now.
So not for now. I think though that you guys are definitely a fast-growing company.
Yep.
Yeah.
So we'll see where that takes you.
Yeah.
So did you consider other cloud vendors? If so, what made you choose Google Cloud Platform?
This one is hard. So I think I'm gonna take this. So probably not right now at this point. So because all of this architecture in GO-JEK is stored in the Google Cloud Platform, we're pretty happy with this. So everything is going well, and it also fits all of our use cases. So we think we're not looking anyone for now because it's already covered all of these things, all of the business use cases.
Yes.
Great. Actually, maybe if we go back to the summary slide, can you take us back?
Yeah. Take the
So
summary.
it looks like somebody wants us to sort of summarize the.
This one, yes.
No, this one. The
This
recap.
one?
This one, yeah. That's
Yeah,
one.
this one. So if you could sort of, I guess, break down, maybe if you could.
It is showing.
Is that shown so people can see it? Okay, great. So if you could sort of, I guess, talk about the different pieces of the architecture, and maybe I'll bring it up here just for ease of use for you. If you could, I guess, talk about the different products in each of these things where you're looking at, I guess, maybe what you're using today. So I guess that dark blue area in terms of your next-gen data warehouse.
Yes. So I think probably Dimas can cover me after this. So some of the Google product that we use, Google product, right?
Yes.
Some of the Google product that we use, we'll start on doing the batch for the big and complex data.
Right.
So one of the use case is we are using the data prop. So for the where we're gonna start using the Spark.
Yeah.
So we're using Spark a lot for processing the complex data, the daily complex batch complex data. This is where we are using the data prop because having the experience of managing the one machine itself is pretty
Hard.
It's pretty hard. So that's why we are choosing the data prop is it can scale pretty good. So everything is already in place. So what we did is we are building one of our team is building the ephemeral cluster. So we just need to have the cluster ready, put some jobs, and bring it down. Something like that.
In terms of storage, we still have the Google Cloud Storage. Of course, the BigQuery is still in place as our data warehouse because it has a very good high performance,
Yes.
right? And then we start seeing about the Cloud SQLs and Bigtable because we are needing it for the transactional databases and the time series databases, right?
Yeah, even right now that we probably say that our database is in Postgres, is not stored in the Cloud SQL. We just have this as a bare metal. So
Yeah.
yeah.
Right. Okay, I understand. So yeah, and those unfamiliar with Dataproc, it's essentially a managed Hadoop cluster. So the work that they're doing with Spark and Hadoop allows you to have this managed Hadoop cluster, which, as you said, could be ephemeral, right? So it allows you to spin up these clusters, process your data, and shut it down when it's not needed in order to save costs.
Yeah.
Sure. And then in terms of operational thing, we will have the deployment manager also, right?
Yeah.
It is coming from the Google thing. So we can have a one-click deployment if you want to create BI in another project.
Yeah.
Right.
That's it.
Let's
This
say
is
for
coming from
expansion or
this.
something.
Yes.
Fantastic.
Yeah.
So how long did it take for that transition? I know you sort of gave some indication, and I would say it's probably fair to say the transition is still going on, right? Because it seems like it's something that's continually evolving.
Yeah. So we're thinking that probably at the first we're trying to move everything to the GCP. Probably like we're gonna migrate our ETL tools to the Dataproc, or we're gonna move all of our data into the BigQuery. But doing it is pretty hard. Doing the migration itself, doing the transition, because we have a lot of type of data, the transactional data that we cannot just put it into the BigQuery, but we need to think on how we're gonna refresh those data, because BigQuery cannot do the update, delete for the partition table at least. So that's where the part is getting hard. So we need to rethink on how we need to push those data into the BigQuery, that kind of thing.
Yes, so for us it can be take around 2 quarters for it, but most likely it will be different for any of you because it is depend on what use case you are, right?
So probably if you have all of the data, for all of your data is eventual, where you only have all of the data recording as historic data, it will be pretty easy. But if you have all of the data that get updated every day, you need to have the update data, that will be pretty hacky to do it.
Yeah, and I think this probably comes back to sort of a question that we had earlier when I did the overview, which is, how do I choose what to migrate? And I think you guys have sort of gone slowly through those choices, right? So being able to do things in batch into BigQuery, that's sort of like an easy place to start because it gives you the sort of that capability around analytics. Then moving more towards, maybe batch into Hadoop or into Google Cloud Storage, and then you can start taking a look at those real-time streaming pipelines.
Yes, correct.
Okay, fantastic. So are you implementing slowly changing dimensions for the dimension tables?
Slowly changing dimension.
Not literally, yeah. So we're not literally like doing the slowly changing dimension. So what we did is we just have all of those data snapshot every day, because we don't have any limitation of storage in here. And the best way, what we think the best way for this transition period, probably we're gonna think it later on, but for now, what is the best way? Just we have one of the snapshot data, put it into a different partition in the BigQuery. So everyone can use the different partition to see what is the condition, or let's say for the customer previous day, and on it go. So that's only for the sake of the migration, because we doesn't really have time to take a look one by one. So we have only a set of rules that we implemented.
So it is easier to maintain 2 parts for now instead of changing or slowly changing all of the people mind into our new dimension.
Right. So it's right for now. It's additive, right?
Yeah.
Just like adding and adding and adding, and you can use BigQuery and its capabilities to query petabytes of data in order to process that and actually give you the view you want.
Yes, we have no problem with that. So
Fantastic. So what kind of programming languages are you using within this technology set?
So probably the main part is we have the Python.
Some
of also Python, I guess, is the most favorite thing in business intelligence in GO-JEK.
In GO-JEK, yes.
And also some of it is depends on the use case, I guess. So for the one that having the capabilities want to control everything, they can just use the Python thing. And also most of the cases as well only need the shell for the wrapper, and they have some specific SQL in there, because we doesn't have that kind of limitation for the SQL in BigQuery. So we can have using the BigQuery Becky command in the Python from the Cloud SDK, and we can just put it in simple wrapper and having work in the production level.
And for sure, I think Google Cloud Platform is also not limiting us to choose only one programming language, right? We can use the Java one, or maybe a Scala one, a Python, everything. But in here, yes, we are mostly using the Python and the shell script one.
Probably we're gonna also moving to Scala for specific reason, like the Dataproc for the Spark thing, and also when we moving into the Dataflow.
Dataflow, yes. Yeah, right. So I think whenever we first released Dataflow, it only supported Java. Of course, now we support Python, and we're looking to support Scala as well, which you guys are taking advantage of. Fantastic. So, so you mentioned that one of the features of BigQuery was about adding descriptions and search terms to tables and columns. Is this a specific feature of BigQuery, or is it an architecture of how you created your data warehouse?
So it is there. It is already provided by the BigQuery about the feature adding the description for the description of the tables until
Yes.
the description of the column names, right? We just use all of this, extracting into one file and combine every files and make an UI for that. Only that we
Okay.
are doing. But
Yeah.
all of this already covered by the BigQuery capabilities.
Yeah, to be honest, this one is the one that we are taking into consideration just for now, because previously in Postgres we never think of this, and when we have the BigQuery we can have sort of the description and name, but it's still pretty hard for some of the use cases, so we are extending those use cases by extracting all of those data. But probably for now on and the future we're going to take this as the architecture of the data warehousing itself. Yes.
Great, fantastic. So what are the tools available to query data on cloud storage? Or maybe to generalize that, do you guys query your data lake directly through cloud storage? And if so, how do you do that?
Some of the use cases, we have the Dataproc and Spark cluster running, and on top of it, we have the Zeppelin. So Zeppelin is the interpreter that we use. It can call all of the Scala function,
Yes.
PSpark, and Scala submit and everything. So on top of that, people just can do the queries, load the data from the Parquet or the JSON tables, JSON files, and they can do the query of it. But we're trying to minimizing a lot.
Yes, and some part of our data lake is on the JSON file where we can easily import the data into the BigQuery, right? Or using the external data sources with the BigQuery.
Because there is some limitation that we have, because if we do the query, let's say based on the Zeppelin with anything, we need to manage the cluster, we need to scale it up when the user is getting big and big. So what we're trying to do is, if only you have a specific use case using Spark, then you can do it. But if it's you can take time and load it into the BigQuery, that's the better part.
Yes.
Yeah, absolutely. And I'll say, again, just for those people who don't know Dataproc, Dataproc itself can actually run directly off of Google Cloud Storage. You don't have to bring that in a HDFS. However, there are some performance considerations. So you really think about sort of, how you want to do that. If it's sort of like a one-off type thing, then it makes sense maybe to do that. However, if it's going to be sort of an operational thing, maybe you want to actually bring that into HDFS.
Yes.
Okay, fantastic. So, yeah, the last question. Have you thought about using Google Spanner as a data warehouse or operational database?
What is it?
Cloud
This one.
Spanner.
Oh,
Cloud Spanner.
So, from my point of view, probably not.
not for now, yeah.
Not for now, yes. We're trying to limiting ourselves, not in a bad way, but limiting ourselves in how we can manage those things. So right now, probably we don't have much of use cases using the Spanner. We're still pretty good having the BigQuery. Probably we'll extend with the big table for now, only for specific use cases like where we're gonna have the key value mapping, key value store.
Yeah.
But other than that, we're not actively thinking on the Google Cloud Spanner.
Yes, correct.
Great. And I'll just say in terms of the operational, Cloud Spanner is much better as an operational data store. Really, if you're looking at doing data warehousing, it's probably not cost effective to
Yes.
use something like Cloud Spanner because it is priced to be an operational store, whereas BigQuery is extremely attractive in terms of a data warehouse because essentially you're just paying for storage and queries. You're not paying for any compute at all.
Yes.
As an additional, also we are coming from the business intelligence department, so we are not that tech savvy to applying everything into our system, but it is based on our use case. We need it or not. That's it.
Great. So a few more questions have popped up here. So what do you think is the best thing about BigQuery, and how do you think it helps GO-JEK?
Well, it's helped a lot. So I'm smiling because this is really, BigQuery is helping a lot.
Yes, yes.
Because we do a lot of analysis. Let's say we need to have the analysis of 1 year data. Our old Postgres cannot handle
Cannot
that. Our growing is pretty huge. It's exceptional data growing. So moving to the BigQuery, I guess, is one of best
Our
our
business,
decision.
yes.
But it's also we have also consideration to taking, let's say, other team in GO-JEK is also building their own Hadoop cluster and etc. But we also comparing to each other what is the best case when using the BigQuery and what is the best case when using your own Dataproc cluster. So we're actively tracking on that. What is the pros and cons? But for now, from my point of view, I guess the BigQuery is helping us a lot to do a lot of campaign, a lot to do the A/B testing and everything. Probably Dimas have different
Yeah, of
view.
course, because I'm part of the operational in data warehouse. Previously, I got so many complaints about, hey, my query is not finished yet. Until now, it's have been 30 minutes and everything, but with BigQuery, it lasts under 1 minute, 2 minutes, everything for the big, huge data that being processed.
Yeah, fantastic. Yeah, I mean, one of the things I do like about BigQuery, it is just sort of like you upload it, you query it.
Yes. As
Right.
simple as that.
Some of the use cases are also like they have the data in here in the Google Sheets, and they can just connect it into
Yes.
the BigQuery, and they do some joining with the
Really,
data in
that-
Google
yes,
Sheets.
using
It's
this
pretty
data
useful.
sources.
Yeah.
Yeah, fantastic. So what are things that you could do now which you couldn't do before with the new generation of data warehousing? I think we covered some of that,
Yeah.
just in terms of the queries that you're doing. Is
I
there anything else you
think-
wanted to add?
Nothing. Everything is already covered.
Yeah.
Okay, great. So, so how do you migrate your data from the legacy data warehouse? So what sort of tools did you use in order to do the migration from your legacy data warehouse into BigQuery?
I guess we're using a lot of tools. Some of the complex one. The design thinking that we have, we're trying to put simplicity first. So during this migration, we're trying to have all of the data based on the ELT process. So basically extract the data, load the data into BigQuery, and do the transform. If it's good enough from the cost perspective, from the performance perspective, it's also pretty good. We are choosing that kind of thing. So we're basically just build some wrapper and call the function from the cloud SDK for the BigQuery, and also just load the data there, transformation and everything. But for the more extreme data, complex processing where it needs a lot of processing power, let's say we are processing daily data by 1 billion at once, we have the Spark cluster as well.
Yes, correct. So actually, I could say with the new data warehouse using the BigQuery, our tools is being less.
Yeah.
We can use a simple shell script to have our data migrating from the Pentaho into the new data warehouse, something like that.
Yeah. So we can have cover all of the general thing with some simple tools, but for the specific things we can explore more.
Yeah.
Right. So in terms of scheduling tools, I mean, I guess you mentioned Airflow before.
Yes.
Is that what you're essentially using for all the scheduling of
Yes.
data into
Yes,
BigQuery?
of course, we are using Airflow a lot in here because we have hundreds of jobs, more than 400 jobs that we are maintaining, and all of them is intercorrelated. So that's why we have Airflow to maintain all of the dependency and the scheduling part. Also, it have the functionality to informing us, alerting us if there is something wrong with the jobs.
Great. And for those of you unfamiliar, Airflow is a scheduling tool that was open sourced by Airbnb.
Yes.
It's entirely open source. You can download that and obviously run that on
Yes.
Google Cloud Platform if you need to. What do you use Apache Spark for? I think we already covered that as
Yeah.
well.
Yes.
For the complex event processing.
Great. And why are you still using Pentaho?
Oh, this is interesting. Probably you should answer.
Yeah.
You should answer this.
Yeah, okay, so why we are still using Pentaho? Because with the BigQuery, we can use the extract load transform thing, right? We can use the SQL query, but sometimes there is still some transformation that heavily used in the Pentaho, and at times if we are using directly to SQL part, so we're still using the Pentaho, but in the next soon probably we will use the Apache Spark for it, right?
Yeah, because some of the business intelligence team is not all of them is a coder. So Pentaho is one of the tools that preferred because they can do click, drag, and drop, and simple logic to do all of the transformation. But we think it's also one of the point is also covered all of the optimization that we need, because let's say if you're using the Python for simple let's say ETL processes for summarizing all of the data and everything, if you don't optimize the code much, it probably doesn't give the same performance with the level that given by the Pentaho itself. But right now, yes, we also migrating from the Pentaho soon, so that's why we have the Python Scala for the on top of the Spark.
Yes.
It's ready.
Okay, fantastic. And is there any second part? No, I think that's it. They haven't refreshed it, so I'm going to assume that there are no more questions. Fantastic.
Okay.
All right. So, Dimas, Johannes, thank you so much. That was extremely
me too.
useful. You shared a lot with us in terms of, I think where you were, where you are, and where you're going. I know that it was a lot to go through, but you did manage to get through all of it. It's amazing. And thank you very much for the questions, and thanks to you guys for answering.
We wanted to thank you also to all of our team there, because it is all of the teamwork effort.
Yeah. Thanks,
Absolutely.
guys. Everything.
Great, yes. Thank you very much to GO-JEK. Thank you very much to Omase as well, who spoke earlier, and to Smart Parking, fantastic customers who are doing a lot of cool things with sort of modernization of their IT frameworks through different methods, through IoT, through Kubernetes and container-based solutions for their applications, and through the data warehousing applications that GO-JEK shared with us just now. I'd like to thank the production team as well as the customer engineers who are helping out with the Q&A, and to the marketing team as well. I get to work with fantastic people and with fantastic customers, and I really enjoy my job. So thank you very much, and we'll see you at the next Cloud on Air.
Thank you.